Fortunately, it now appears that effective vaccines are just around the corner. We have now seen data for pivotal trials for a number of lead candidates. Both lead mRNA products, one developed from Pfizer in collaboration with BioNTech, as well as Moderna, have demonstrated very effective efficacy, both attaining a 95% level of reduction in the risk of getting infected versus the placebo arm, which by many has been regarded as exceeding the highest expectations with that respect. Both products thus far appear to be safe, and both companies will be filing for regulatory approvals or have done so with the expected entry into the market in most developed countries before the end of 2020. However, for both products, we do have to focus on the limitations of these studies. Number one, we have witnessed efficacy with only a few months of follow-up, and the amount of safety data is thus far limited to 2 months following the vaccination. The other major candidate in development, which is the viral vector approach from AstraZeneca in collaboration with the Oxford University, has demonstrated efficacy that appears to be not as high as the mRNA vaccines, yet nevertheless, another candidate that has successfully completed the pivotal trial. We are still awaiting for more data coming out next year from the final analyses of these studies, as well as pivotal trial data readouts from the more traditional subunit-based approaches, as well as other approaches to vaccinations. Regulatory agencies all over the world will most likely grant an expedited approval. However, given the fact that the data from these studies is relatively limited, the initial rollout of these vaccines will be in the high-risk populations only. The broad-based vaccinations that will impact the larger populations in key developed markets are more likely to be deployed in the middle of next year. The critical question that remains at this point is the durability of the vaccine-induced protection against SARS-CoV-2, and therefore the ability of these vaccines to prevent COVID-19. Here, it is important for everyone to understand that there are two major reasons why the level of protection would wane over time. Number one, the immune response itself could be diminished as the immune system simply depletes its memory of the virus that is induced by the vaccine or even a normal infection. The second is that the virus itself may evolve to a point where it simply evades the immune response by changing its structure in such a way that it is no longer similar enough to the structure that was originally presented to the immune system by the vaccine. The best available data at this point is somewhat reassuring with respect to both of these major issues. Number one, it appears, looking at the levels of immunity from individuals that have been infected with COVID-19, it appears that that level of immunity, specifically the memory component of it, is maintained for a relatively extended period of time. The best guess is that at least a 1 or 2 year period of time should be expected to have sustained level of immunity following the vaccination, with possibility of that period of time being significantly extended. The second reassuring element is the actual viral evolution. And so far, we did notice a number of various strains that have evolved in different parts of the world, and of course, a natural range of mutations within the virus. However, COVID-19 virus SARS-CoV-2 is thus far not exhibiting structural alterations that are profound enough to make us believe that it can evade the immune response. Nevertheless, it is important for everyone to understand that it is feasible that repeat vaccinations in form of boosters a few years after the initial rollout with the vaccines could be required to address COVID-19, it is also possible that the vaccination development may include an introduction of new candidates to deal with these issues as the situation with the pandemic evolves.